Rana Plaza collapse. Rana Plaza collapse was a structural failure of a commercial building in Bangladesh that killed over 1,100 garment workers in 2013. The 8-story Rana Plaza building stood in Savar, just outside Dhaka. It housed several garment factories producing clothing for international brands. On April 23, large cracks appeared across the structure. Local authorities ordered the building evacuated. Shops and a bank on the lower floors closed immediately. But the factory managers faced production deadlines. Workers were told the cracks were harmless. Many later said they were threatened with losing a month's pay if they refused to enter. The next morning, April 24, thousands of workers returned. Heavy industrial sewing equipment filled floors that had never been designed for that level of load. The building itself had originally been permitted for only 5 stories. 3 additional floors had been added without proper reinforcement. Even more dangerously, large electrical generators had been installed on upper levels. When power outages hit that morning, the generators activated, sending vibrations through an already compromised structure. At 8:57 a.m., the building collapsed in less than 90 seconds. Entire floors pancaked onto each other. Stairwells disintegrated. Workers were trapped between concrete slabs, sewing machines, and steel rods. Rescue crews spent weeks cutting through debris. The death toll eventually reached 1,134 people. More than 2,500 others were injured. Investigations revealed systemic corruption in building permits, ignored safety warnings, and intense production pressure inside the global garment supply chain. The structure did not simply fail. It had been failing for years. And on the morning of April 24, it was still full of people. Hyatt Regency walkway collapse. On the evening of July 17, the Hyatt Regency hotel lobby was full. More than 1,600 people had gathered for a weekly tea dance event. The hotel's open atrium featured several suspended walkways crossing above the lobby floor. Guests stood along the railings, watching the crowd below. At 7:05 p.m., 2 of the suspended walkways suddenly collapsed. The 4th floor walkway fell first. It dropped directly onto the 2nd floor walkway beneath it. Both structures then crashed onto the lobby floor where hundreds of people were standing. The collapse happened instantly. Many victims were crushed under tons of steel, glass, and concrete. The design flaw had existed long before the building opened. The walkways were suspended from steel rods connected to the ceiling structure. In the original engineering design, a single continuous rod ran through both walkways. During construction, the fabricator proposed a modification. Instead of one long rod, 2 separate rods would be used. This change doubled the load on the connection points holding the 4th floor walkway. The revised design was approved without a full structural review. For months, the connections quietly carried far more weight than they were designed to support. On the night of the dance, the crowded walkways exceeded the already unsafe load. When the connections failed, the upper walkway dropped directly onto the lower one. The collapse became one of the deadliest structural failures in U.S. history. More than 200 people were injured. Rescue workers spent hours pulling survivors from beneath the debris. Investigators later concluded the disaster resulted from a design change approved without adequate engineering verification. The building did not fail because of a single mistake. It failed because a small change was treated as routine. Quebec de la Concorde overpass collapse. On September 30, the afternoon traffic on Autoroute 19 was routine. Cars moved steadily beneath the de la Concorde overpass, a concrete structure built in the early 1970s. The bridge carried vehicles across the highway above, while traffic passed beneath through several lanes. At 12:30 p.m., a large section of the overpass suddenly broke away. The concrete slab forming part of the bridge deck collapsed downward onto the highway below. Vehicles traveling underneath had almost no warning. Several cars were crushed under the falling concrete. Others crashed while trying to stop. Emergency responders arrived within minutes, but the damage had already been done. 5 people were killed. 6 more were seriously injured. Investigators later discovered that the failure had been forming for decades. The overpass had been built with reinforcement steel, placed too close to the surface of the concrete. Over time, water and road salt seeped into the structure during harsh Canadian winters. The steel inside slowly corroded, expanding as rust formed. As the steel expanded, it cracked the surrounding concrete. These cracks allowed even more moisture to enter the structure. The damage progressed quietly beneath the surface where it was difficult to see. Maintenance inspections had noted deterioration, but the severity was underestimated. Engineers later found that parts of the structure had been significantly weakened long before the collapse. When the final section failed, the rest of the slab followed almost instantly. The disaster triggered a province-wide review of bridge safety across Quebec. The overpass had stood for more than 30 years. The conditions that destroyed it had been developing almost the entire time. Sampung Department Store Collapse. Sampung Department Store collapse was the structural failure of a large shopping mall in Seoul that killed 502 people in 1995. The Sampung Department Store stood in the busy Seocho district of Seoul. It was a massive 5-story retail complex visited by thousands of shoppers each day. On June 29, the building was full during the late afternoon rush. But the structure had been compromised long before that day. The building had originally been designed as an office complex. During construction, the owner decided to convert it into a department store. This change required wider open spaces for retail floors. Several structural support columns were reduced in size to make room for escalators and larger shopping areas. The alterations weakened the building's load-bearing capacity. Later, a heavy air conditioning system was installed on the roof. When the equipment needed to be repositioned, it was reportedly dragged across the rooftop instead of lifted by crane. The movement damaged already stressed structural columns. In the months before the collapse, large cracks appeared across the upper floors. Pieces of concrete began falling from ceilings. Some employees reported hearing loud cracking sounds coming from the structure. On the morning of June 29, engineers warned that the building was in serious danger. Instead of evacuating immediately, management closed only part of the top floor and kept the store open. Business continued while the damage worsened. At approximately 5:57 p.m., the roof gave way. The upper floors collapsed downward in a rapid chain reaction. Entire sections of the building folded into themselves within seconds. Thousands of shoppers and employees were trapped under concrete slabs, steel beams, and debris. Rescue crews searched through the ruins for days. When the operation ended, 502 people were dead and nearly 1,000 more were injured. Investigations later concluded that illegal structural modifications and ignored warning signs had made the collapse inevitable. The building did not fail suddenly. It had been warning people for months. Silver Bridge Collapse. Silver Bridge collapse was the sudden failure of a suspension bridge over the Ohio River that killed 46 people during rush hour in 1967. The Silver Bridge connected the towns of Point Pleasant, West Virginia, and Gallipolis, Ohio. Built in 1928, it carried thousands of vehicles across the Ohio River each day. By the late 1960s, traffic volumes had grown far beyond what the bridge had originally been designed to handle. On December 15, during the evening commute, cars filled the bridge from end to end. Traffic slowed to a near stop as drivers waited at a traffic light on the Ohio side. At 5:04 p.m., the bridge suddenly failed. Witnesses described a loud metallic sound, followed by the entire structure collapsing into the river below. Vehicles, trucks, and sections of roadway plunged into the freezing water. Some cars were trapped beneath falling steel towers and cables. The cause of the collapse was extremely small. Investigators later found that one of the bridge's suspension links contained a tiny crack known as a stress fracture. The crack measured only a few millimeters deep. Over years of repeated stress, the fracture slowly grew larger. The Silver Bridge used an unusual design called an I-bar chain suspension system. Unlike modern cable systems, the failure of a single I-bar could cause the entire structure to collapse. That is exactly what happened. When the cracked I-bar finally snapped, the bridge lost its support almost instantly. The structure had no redundancy to distribute the load elsewhere. Within less than a minute, the entire bridge was gone. Rescue teams searched the river for days. 46 people were killed. Many victims were never recovered. The disaster led to major changes in bridge inspection programs across the United States. The fracture that destroyed the bridge was smaller than a coin, but the design left no room for it to exist. Westgate Bridge Collapse. Westgate Bridge collapse was a construction disaster in Melbourne, Australia that killed 35 workers during the building of a major highway bridge in 1970. The Westgate Bridge was being built to span the Yarra River and connect Melbourne's growing western suburbs with the city centre. It was one of the largest infrastructure projects in Australia at the time. Hundreds of workers were involved in assembling the massive steel box girder sections that would form the roadway. During construction, engineers noticed that two large steel spans did not align properly. One side of the structure sat higher than the other by several centimeters. Instead of disassembling and correcting the fabrication error, a decision was made to force the sections into alignment. Workers attempted to correct the problem by placing heavy concrete blocks on top of the steel structure to push it downward. The added weight created enormous stress inside the steel box girders. As pressure increased, the steel plates inside the span began to buckle. Witnesses later reported hearing loud cracking noises coming from inside the structure. The distortion was visible to workers on the bridge. Instead of evacuating immediately, attempts continued to fix the alignment. Shortly before midday on October 15, the entire 112-meter span suddenly collapsed. More than 2,000 tons of steel crashed to the ground below the bridge. Workers standing on the structure were thrown into the falling debris. Others were crushed beneath the collapsing girders and construction equipment. 35 construction workers were killed. Many others were injured. Investigations later found that a series of engineering misjudgments and rushed decisions had pushed the structure beyond its limits. The collapse became one of the worst industrial disasters in Australian history. The structure failed while it was still being built, and many of the warning signs had been visible to the people standing on it. Big Bayou Canot Train Wreck. Big Bayou Canot Train Wreck was a bridge failure in Alabama where a passenger train struck a displaced railway bridge, killing 47 people in 1993. In the early morning hours of September 22, dense fog covered the Mobile River Delta in Alabama. A towboat pushing several barges through the Big Bayou Canot waterway lost its bearings in the fog and drifted off the navigation channel. The barges struck the railway bridge that crossed the waterway. The impact did not cause the bridge to collapse immediately. Instead, it shifted the steel structure several feet out of alignment. The rails remained in place, but the track was no longer straight. No automatic warning system detected the damage. Minutes later, Amtrak's Sunset Limited passenger train approached the bridge at full speed. The engineer had no reason to slow down. From a distance, the track appeared normal. When the locomotive reached the bridge, it hit the misaligned rails. The engine derailed instantly. Several train cars slammed into the bridge structure and plunged into the dark water below. Others piled onto the collapsed span as the bridge finally gave way under the weight of the wreckage. Passengers inside the cars had only seconds to react. Some cars filled with water as they sank into the bayou. Rescue crews struggled to reach the wreck site in the darkness and fog. 47 people were killed and more than 100 others were injured. Investigators later concluded that a single navigational mistake by the towboat crew had displaced the bridge enough to create a deadly trap. The train arrived only minutes after the bridge had been struck. No one knew the tracks were no longer where they were supposed to be. FIU pedestrian bridge collapse. FIU pedestrian bridge collapse was the sudden failure of a newly constructed pedestrian bridge at Florida International University that killed 6 people in 2018. The bridge had been installed only days earlier. It spanned 8 lanes of traffic near the university campus in Miami. The project was promoted as an example of accelerated construction methods designed to reduce disruption to busy roads. The main span of the bridge had been lifted into place on March 10. Traffic resumed underneath shortly afterward. Within days, engineers noticed large cracks forming in the concrete structure. On the morning of March 15, a meeting was held between project engineers and contractors to discuss the damage. One of the most serious cracks ran diagonally across a major support node, connecting the bridge deck to one of the main truss members. Despite the visible damage, traffic beneath the bridge remained open. Engineers believed the cracks did not represent an immediate safety threat. Workers were sent onto the bridge to tighten steel tension rods in an attempt to reduce the cracking. At 1:47 p.m., the structure suddenly failed. The 950-ton concrete span collapsed directly onto the roadway below. Several vehicles were crushed beneath the falling structure. Workers on the bridge were thrown into the debris as the truss sections shattered. Emergency crews arrived quickly, but much of the damage had occurred instantly. 6 people were killed and several others were injured. Investigators later determined that a critical design error had severely underestimated the stresses at the cracked joint. The widening cracks were a sign that the structural connection was already failing. The bridge collapsed while engineers were actively attempting to repair it. The warning signs were visible, but the structure did not wait.